In today's lesson, we're going to compare linear relationships to one another. And the way that we're going to do that is we're going to compare tables to graphs, tables to equations, graphs to equations, and so on. So let's get right into it. The first question is saying, or it's asking us, in which of the following is y increasing faster? So what this is asking us for is the rate of change. Which one has the greatest or fastest rate of change? So, and if you recall, the rate of change is the change in y compared to the change in x. So it's the change in y, and we can write that as delta y over delta x. So let's look at the rate of change in the table first. So my y value increases by 7. The x value increases by 1. The y value increases by 7. The x value increases by 1. So in the table, we have a rate of change of 7 to 1, which is 7. So there's my rate of change for the table. Now let's look at the graph, and we'll find the rate of change there. So for this, I need to pick a point on the line. I'm going to pick, I'll do it in red, right here where the line goes perfectly through the y-axis. Now I also need a second point on the line, and it looks like right here. The line goes perfectly through those grid lines. So again, let's compare the change in y to the change in x. I'm going to zoom in. So if I start at 3 and I go upwards, my y just changed by going up 4. And then I went over 1 on the x-axis. So this is up 4 plus 1. That is a rate of change of 4 to 1, or 4. So which one has the greatest rate of change, or which one is the y increasing faster? The table is. The table has the faster increasing y. Let's see if we can try this with another one to shore up our skills on this. So again, we're asked to decide which linear relationship has the y increasing faster. We've got the table compared to the graph. So to find the rate in the table, we're going to compare the change in the y. In this case, the y is increasing by 4. And comparing it to the x, which is increasing by 1. The y is increased by 4 again. The x is increased by 1. So this is a rate of 4 to 1, which we can simplify to 4. In the table, it was 4. In the graph, we need to pick a starting point again. And it's hard to see, but it looks like the line goes perfectly through the origin. And this one didn't provide me with very nice grid lines to look at, but it looks to me as if maybe right here. So that looks at 1 on the x, 5 on the y. So I'm going to count up from 0 to 5 is plus 5. And then we went over 1. So that is a rate of 5 to 1, or 5. So in this example, the graph has the y that increases faster. The third example is asking us to find which linear relationship has the greater y-intercept. So be careful as you're doing the problems that you don't get stuck in a rut just thinking about the rate of change, because now we're looking at the y-intercept. So in the first example here on the left, we have graph of a line with a slope of 7 that crosses the y-axis at 5. Well, here's our y-intercept. If I was to graph this out, right, here's my y-axis, here's my x. The y-intercept would be at 0, 5. It would be right there. On the right-hand side, the linear relationship is y equals negative m multiplied by x plus 7. So this is in slope-intercept form, and my y-intercept is right there, and it's positive 7. So I'm comparing which one has the greatest y-intercept. It's this. This one has a y-intercept of 7, so it's higher up on the y-axis. If I was to draw a graph for this one, it'd be at 7 on the y-axis. In our fourth example, we're asked in which of the following linear relationships is y changing more rapidly? So don't fall into a trap here. We're not asking which one has the faster increasing. We're asking which one's changing more rapidly. So one could be increasing, the other linear relationship could be decreasing. Which one's changing more rapidly? Right? Is one decreasing at a faster rate than the other one is increasing? So let's have a look at these. We've got a table and a graph again, and we'll determine the rates of change. So in the table, the y increases by 5, the x increases by 1, increases by 5, increases by 1. So here we have a rate of change of 5 to 1, or 5. Now let's look at the graph, and again, we need to find a point on the line, and it looks to me like there's a point right here. That looks like it's at 3. Then I need a second point. And very tricky, but I believe right here, that is 1, negative 4. So I'm going to use those 2 points. So we're going down to negative 4. So let's count the rate of change. We're going down 1, 2, 3, 4, 5, 6, 7 units, and then we're going to the right 1. So this has a rate of change of negative 7 over 1, which is negative 7. So which one is changing more rapidly? The graph. That has a steeper slope than the table. In our final example, we're asked to consider the equation of y equals 6x plus 1 to the line on the graph. So which one does the line y equals 6x plus 1 have a larger or smaller rate of change? Well, we know from the equation that the 6 is our rate of change. That's our slope. Now we need to find it in the graph. So again, we pick a point. That to me looks like it's a positive 1 on the y-axis. And then we need another point. So for my second point, it looks to me like right here at about 10 on the y-axis, I have a point here. If I was to draw a line straight down, that looks like 3 on the x-axis. So I'm going to use that point. So to find the rate of change here, we would count up. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That goes up 9. And then we go across 3. So a rate of 9 over 3, which is 3. So to answer the question, does the line y equals 6x plus 1 have a larger or smaller rate of change? Well, the line had a rate the line on the graph had a rate of change of 3. The equation has the rate of change of 6. So y equals 6x plus 1 has a larger rate of change. That's our assignment for today, is to go through some problems like this and just make comparisons. If you have any questions, email me and I'll get back to you as soon as I can. Have a good day.